Hello guys, welcome to Placebo to Edu and my name is Vinay Kumar Nainapatrani. Today we are going to do the analysis of resistors and in that it is part 1. In part 1 we are going to learn the series combination of resistors with simulations. Let's get started. Considering two resistors R1 and R2, let this be the voltage source V. Okay, this combination is known as series combination. We have voltages across resistor 1 and voltage across resistor 2. Okay, and the current through resistor 1, which is I1, and here the current through resistor I2, and the current through voltage source is I. These all are the terms which we have to define. So the current through voltage source is I and the voltage source value is V, and here the voltage of resistor R1 is V1 and the current passing through is I1. What will happen in series combination? That means what will be the relation between I1 and I2? What will be the relation between V1 and V2 and V? Let us see. Before seeing that, let me show you the simulation of this circuit such that you can understand it better. Coming to the simulation, here I took 1k, 1k, and this one is 10 volts. Okay, voltage is 10 volts and the two resistors are 1k and 1k. Now I'm going to simulate it. See, the yellow color uh, dotted line is seen in the diagram, which represents as the current is flowing. In order to know what is the value of current flowing through the circuit, I'm going to show you in this way. So 5 milliamperes is the current flowing through the circuit. But what is the value of current flowing through 1k? It is nothing but 5 milliamperes. And the same can be seen in this also. Understood? Now I'm going to stop the simulation and check the values. Okay, stop. This is 10 volts and this is 1k, this is 1k. We have the voltage is 5 volts and the current through resistors is 5 milliamperes, and here the voltage is 5 volts and the current through resistor is 5 milliamperes. So our analysis will be, if this is 1 kilo ohm and this is 1 kilo ohm, our current I1 is equals to 5 milliamps, I2 is equals to 5 milliamps, V1 is equals to 5 volts, V2 is equals to 5 volts, V is equals to 10 volts, and I is equals to 5 milliamperes. This is what we got from the simulation. What if the resistor which is here is changed to 10 kilo ohms? What if it is changed to 10 kilo ohms? Will there any change in the currents? Will there any change in voltages? What will be the overall current? Let us see now. I'm going to change this to 10 kilo ohms. Okay, and running this, there will be a considerable change which I'm going to show you. I stopped the simulation. See here, voltage across the 10 kilo ohms resistor is nothing but 9.09 volts. Before that it is 5 volts, but it changed to 9.091 volts. And the voltage across 1 kilo ohm is from 5 volts, it changed to 909.091 millivolts. Understand? So now the voltage is changed from 5 volts to 9.901 volts, and here V2 is nothing but it is changed to 909.1 millivolts. This is the source, so it will be nothing but V equals to 10 volts, and the current is changed to, if you observe it carefully, the current is changed to 909 microamperes. Understood? So now I am writing the current is changed to 909 microamperes. What will be I1? What will be I2? Let us see. I1 will be, see here, it is volts, and if we come down, we can get the I1. I1 will be 909.091 microamperes, and I2 will be 909.091 microamperes. So I am going to write the I1 there. It is nothing but 909.1 or something microamperes, and here also 909.1 microamperes. What we observed is, whatever may be the resistors values, the current through them will remain same. So here I am going to write the conclusions. In series, current through resistors will remain same. This is very important line. In series, current through resistors will remain same. Very important. And the voltage will be divided according to some constant or something. Okay, the voltage is being divided. How can we know that? In what ratio the voltage is divided? For that, we have to write the KVL. KVL is for loops, so I am writing a KVL. Since this is minus and this is plus, when writing KVL, I already told you in the basic level video that when writing the KVL, if we are in the path that the potential is increasing, we have to write it as plus V. Okay, after that I am going to jump from positive to negative, that is potential is decreasing, so it will be minus V1, and similarly for V2 it will be minus V2. Therefore KVL will be V is equals to V1 plus V2. That's clear, right? I've already said that V is equals to I into R is nothing but R equivalent. Okay, R equivalent means the whole resistance, and V1 is nothing but I1 into R1 plus V2 is I2 into R2. Okay, if you observe here, we have I1 5 milliamperes, I2 5 milliamperes, and I is 5 milliamperes. I1, I2, I is every time same in series. That's what here this point says. In series, current through resistors will remain same. So from this point, I am considering that I is equals to I1 is equals to I2. So I can replace all I1, I2, I3 with I's. I3 is not there. If I3 is there, you have to replace it with I. So I R equivalent is equals to I R1 plus I R2. Cancelling all I's, we will be left with R equivalent is R1 plus R2. This is very important relation, that when two resistances, that is R1 and R2, are kept in series, the resultant resistance will be nothing but the sum of the resistances. Understood? So the resistance which can be seen from here will be R equivalent, that is nothing but R1 plus R2. Okay, next thing, what will be the voltage? That's our main aim actually. So what will be the voltage there? I've already said I is equals to I1. We have R equivalent. So from Ohm's law, Ohm's law is nothing but V is equals to IR. So I is equals to V by R. So I is equals to V by R equivalent, which is equals to I1 V1 by R R1. Therefore V1 will be R1 by R equivalent into V. We know R equivalent is nothing but R1 plus R2, okay, into V. And this is another important relation, that therefore V1 is equals to R1 by R1 plus R2 into V. And if we continue this method for I is equals to I2, we will get V2 is equals to R2 by R1 plus R2 into V. Understood? This, in this way we got voltages. So here in the first case, R1 is 1 kilo ohm and R2 is 1 kilo ohm. Therefore, the voltage is divided equally, 5 volts, 5 volts. Okay. For that, I am going to explain here. R1 equals to 1 kilo ohm, R2 equals to 1 kilo ohm, which implies V1 will be 1 kilo ohm by 1 kilo ohm plus 1 kilo ohm into 10 volts. Okay. 1 by 2 into 10, 2 5s, and this kilo ohm and these kilo ohms will be cancelled, so 5 volts. Understand? Similarly for V2 it will be 5 volts. Therefore we got here 5 volts and 5 volts. But in the next case, I changed this R1 to 10 kilo ohms. So the factor will be such that 10 kilo ohms by 11 kilo ohms into 10 volts. This quantity will be changing according to the resistances. So the based on the resistances, the voltage across them will be changed in series condition, in series combination. Okay, so voltage will divide based on the values of resistors. That's the point. So in series we have current through resistors will remain same whatever may be the value of resistors, and voltage will divide based on the values of resistors, and the R equivalent will be R1 plus R2 in series, and the voltages will be this one, voltages will be this one. This is very important relation which you have to remember.
Hope you guys enjoyed this video. So please like, share, comment and subscribe. If you guys didn't like this video, please let me know through comments what are the developments to be done. Thank you.